All right, so this is a talk on migrating from CSM to OpenCHAMI with all the context you just got. So, just kidding. Hey, all right. All right, so this is all going to start. I can't read that with that wave. But there's lots of stuff we're going to talk about. First, there's some people at Lanel and HPE that were very helpful. Kind of explain why we're doing this. And then, since I didn't have like a ton to show for the actual migration, I'm going to talk about what how the migration is going to be a little more different than just like a standard drop-in replacement. And then the getting to know your hardware part of this, right? So I'll explain a little bit more about that, and then we'll do some stateless service nodes, doing the actual conversion, what's like the rough plan, and then so sort of some of our current and future global services, and that will make sense later. Okay, so a lot of patient people have been very helpful in this process. So we have a platforms team, think sysadmins, and we have network team, pretty self-describing. HPE, so there's like two people that really sort of helped me figure out the hardware part of our EX systems. So Harold Longley and Michael Buckman answered a lot of my asinine questions on Slack, so it's always appreciated. Yeah, so the why are we doing this? I guess the first, and it's an order of importance, CSM is end of life, so we got to do something. We have a lot of new stuff coming in FY 26, 27. And this leads into we don't have the people to support both of these systems, especially CSM. CSM has a lot of overhead, and so we want to get rid of it before we have to integrate the new stuff. So we're trying to help ourselves instead of hurt ourselves. And we're trying to do a more cloud-like management style. So, we want artifacts we can, interact with, and then sort of like chains of workflows instead of, reactive admins trying to fix things. Okay, so I call this the quest. And it's the quest to stop deploying supercomputers at Lanel, which sounds weird. But the idea is we buy lots of clusters and systems. That's not always the model every site has, but we, for funding reasons and lots of historical reasons, we buy many systems, which means many management planes, which means lots of overhead. And so we also have multiple networks, and like the fun one is air-gapped, right? So that already has its own challenges, and if we have this challenge X+1 number of times, it's very annoying. So having all this together makes it super annoying to deploy traditional HPC clusters, especially with more complex workflows. We're just repeating ourselves so many times. We're just copying our management plane, drift happens, and then the admin overhead is high, right? So getting people to come to live in Los Alamos and work at Los Alamos is sometimes a challenge, right? So the admins, if we can ease their lives a little bit, it'll be better for us, for everyone. The idea is like, let's stop doing this to ourselves. Share configs when possible, not just, like system configs, but, share resources between all the different clusters that we buy. And reduce repeated work, and then just generally eliminate pain that we experience by doing this. Okay, so the quest is really just, let's just manage a data center instead of a bunch of clusters. So we stole this language from NIST 800-223, which is like the HPC zone and the management zone. And we're calling something like, okay, so we have global management zones and local management zones. And the idea is that we put as much stuff in the global management zone as possible, where it makes sense, right? And then we put things in the local management zone that make sense there. So, global management zone, think like your Kates, OpenShift kind of thing, or whatever, sort of site-wide orchestration tools you can use. You can do your DevOps here, so you can do image builds, right? So you don't have to do image builds on every single cluster. You just dump it into this thing, and you get your images out. And then, config testing, deployments, all your sort of normal DevOps workflows. And the local management zones are for unshared services. So think services that need to be close to hardware, BMCs, image distribution, maybe, maybe not, depends. And then you can sort of have multiple local management zones for specific uses, and you can sort of limit the blast radius of a change, right? So you push something out, and you limit it to a local zone for testing, and then you can sort of iterate that thing out. I have man, the colors are awful on this thing. Okay, so yeah, so like data-centric zones, global management zones, something like image build, right? So we put our pipeline, it's already there, it's already a service we have in our global management zone. Put our pipeline there, they spit out images, and we can like use those images as artifacts for all of our local management zones. So local management zones can pull them, or they can just say, hey, you, my subset of nodes that I manage, this is the image you would use. We were also moving our image projection to a more global management zone sort of framework, where the compute nodes boot from a sort of shared file system that our file system teams manage, and this just continues to simplify our local management zones into something almost ephemeral, right? So where you don't have to care about it so much anymore. And the same for like an OCI registry, GitLab. You know, we have Versity S3 now. We haven't used that a lot just yet. I think it just became available as like a shared service. And then we didn't put like, you know, this is where you put your vault, right? Something, or I guess you could if you wanted to. You put your vault in there and then have your local management zones, you know, sort of pull those things when needed. And the other sort of half of this is sort of breaking up like responsibilities, right? And I think this can sometimes be misinterpreted, where we're not saying, you know, like the Slurm team is like completely on their own now, you know, like don't come talk to us, you have your own little box, right? It's really about empowering those teams, because a lot of the times these people have to go through your sysadmins, right? So they need something done, and they got to make a ticket, or they got to go to an office, or chat someone. And this is getting them involved in the process and giving them, like empowering them to make the changes they need, while benefiting from all the infrastructure we're setting up, right? So it's not cloud-like, but it's moving to a cloud-like sort of environment, where they can set things up, and then they can take a benefit of all the services we have, and then they don't have to care like how a node boots or how it configures. They just need to know their little piece, and then they have control over that. And then they want to push updates or whatever, then they have the power to do that. So yeah, I hope one day that our admins no longer have to SSH to like some sort of management node and then run commands to manage the system. I'd love to have a web login, and they just do things on their laptop, and run commands, no tunnels, no whatever else. So that would be, I think, a better workflow, even though they don't know it yet, I think. So yeah, and so we haven't even talked about the HPC zone, right? Yeah, go ahead. Yeah.
Do you see involving the network team in that, or are they just involved in the system?
Yeah, so I think so.
Like as a local zone?
Yeah, so I think so. I think sometimes it depends on what your network team does, right? So a lot of times our network team is like, traditionally it depends on the vendor, right? So the vendor, you know, we'd write contracts, and the vendor would be responsible for like maintaining like the high-speed network, right? And that's kind of changing as we're going forward. So yeah, I think the network team would have a zone, but it gets interesting because the network team cares more about the cluster than I think the admin team does, right? Because when you buy a system, right, you're generally like buying a fabric domain, and they might care about that more. So, but there's things like fabric managers, right? So we're kind of doing this now where, you know, we build out like a base image and some configs to make sure that like a node can boot, and then they start adding their fabric stuff on top. And you have to deploy that per whatever fabric zone they want. But yeah, so I think the networking teams or whatever that is will probably have like a local management zone, but it may be more like broad than maybe some other teams would be, I think. So,
Makes sense, yeah.
yeah. Shit, what time is it? Okay, yeah, so getting to know your hardware. So, yeah, it's all redfish, right? So, and it was true for, you know, the EX stuff. So I actually thought about putting like way more descriptions of EX hardware here, and I thought like, I don't think HPE may appreciate that. So, and I didn't want to ask. So I was too lazy to ask, you know. So it's all redfish. That's the point. No comments on the quality of redfish, but it's all redfish, right? And it's actually pretty usable. Like I'm being facetious for the most part. Yeah. So this is kind of, we talked about this EX bootstrap thing and the need for it, and it was really like a sort of just get it done. I think we talked about this a little bit earlier, but you know, get it done and just get something usable that I can use to get these systems booted. And we do have EX hardware running, managed by OpenCHAMI. It's just we didn't convert anything, so it was brand new hardware. We set it up, so we've gone through that process at least. But yeah, so you know, the idea is you generate these BMC macs, they're algo macs. You generate them, you spit them out into a file, you populate your SMD. Core HTTP does things. You boot BMCs, you discover nodes, and you boot nodes, right? So that's the overall workflow. The Redfish API stuff, like once you get it down, it's the same everywhere. It's the same hardware. So it's not too bad. It was actually like, I was a little worried it was going to be difficult, like really difficult. And it was going to be super confusing. But like once you, I don't know, sort of remove the CSM complexity layer, right? Like the actual hardware is actually like pretty decent, right? Like, you know, I mean, there's always improvements, right? You always have complaints, as you know, like I always have complaints anyway. But just interacting with the hardware was pretty nice, and then, you know, getting things to work was easier than I thought. So, so yeah, so we, you know, getting things actually configured. You know, we've been leveraging this Cloud Init metadata service, and I was going to put like a big graph here of like all of our groups, but I didn't want to confuse people because it's a lot of, we've done a lot of work in this, but we've been taking these cloud configs and sharing them. So we've been building, it's almost like Ansible roles, but like way tiny, super tiny, run fast things, and so bringing in new hardware, like adding a new like section of the system, doesn't take that long. You just fill out metadata and you go, and it just brings it in. And I'm hoping this translates to the conversions, because it's like super easy, right? So you write this template, it spits out a file, and then you write your Crony configs. This is a smaller screen than I was expecting, but it's just Jinja, right? So if you've done Jinja templating before in Ansible, it's the same thing. Well, yeah, and so you just reuse that and just populate new metadata in, and just ready to go. Yeah, so this kind of talks about some of the domains. So like Slingshot Fabric Manager, the Slurm controller, these are all nodes that the teams have been responsible for, and the admins sort of help set up, right? So there's all these basic cloud configs that do like basic things like allow SSH, you know, Crony, syslog, all these fun things. These teams come along, they add their new stuff on top. They don't have to care about the other stuff, ready to go. So yeah, so this is the rough plan for the conversion, and it's very rough because we haven't tried it yet. And the context is we were going to do it, and then the CDU died on our little test system, and it was like, all right, we'll wait, we'll go back. All right. So all these switches have DHCP helpers, and that's how DHCP works. It forwards to like a server, and then, you know, the exchange happens. So what we're going to do is just change that to the OpenCHAMI core DHCP. Let's see what happens, and if it breaks, we just change it back. Don't touch CSM, don't change anything. We've actually tried this before. We deployed OpenCHAMI within the CSM Kubernetes, which was weird, but it did work. So we know this works in some cases, or at least in one case, and then we just need to get it, we just need to try it out. Yeah, all right. So yeah, all we're gonna do is change those. And then this is sort of like the visual part of that. So we figure out a switch domain, we swap it to OpenCHAMI, leave CSM running, and then hopefully it all goes well. And then if it does, we can X out that CSM. If it doesn't, then program managers don't get super pissed at us for killing their systems. So this is just what our pipeline looks like. So we build our image pipeline like this. It's a global service. And you can click on all these. If you've seen GitLab pipelines before, you can click on the boxes. So I'm being told to run. I'm running out of time. And we built a lot of images. So it's almost 600 gigs of our GPU images, just pipelines going. And that's with the reaping service that runs for unused layers. But that's the point, right? It's like we can run this whenever we want, all the time. So. Yeah, so some of these just future global services, we're going to do more DevOps on Cloud.net, render some templates before they ever see the system, inject the metadata, have everything render before, and then the vast backend for image hosting is going to be our new global service. So, oh, and I didn't make a thank you slide, apparently. Hey, all right, I'm done. All right, so if you have any questions, happy to answer them. Kicked off the stage or what?
But since you started a little bit late because the break ran long,
Oh.
we got like 2 minutes for questions, and then we'll bring up our next presenter. Yeah.
Oh yeah, that's where I got the mic.
I think you guys kind of mentioned this, and I might have missed it, but you said you tried switching, migrating a system already from CSM, and it didn't work. Like, I'm just curious.
Oh no. So we did two things. We did a test swap of these DHCP helpers by deploying the OpenCHAMI services within the CSM Kubernetes. So we just made a new namespace, deployed it, and then swapped the helpers to the new service IP. The second was, we were ready to go, and then the CDU, the cooling distribution unit, died, and it needed hardware replacement. So we're just on a week-long pause before we start trying this out. Yeah. So that's the state of our conversion right now. So, yeah. Go.
Anyone else? Yeah. Nor.
Out of curiosity, which version of CSM have you tested in this case?
Oh, this is 1.5.
1.5. Okay.
Yeah, and we are not upgrading it because we're getting rid of it. So, man, I shouldn't say this out loud. We're not upgrading it, I hope. Yeah. So, yeah.
All right. Any other questions? All right. Another thank you for Travis, and then.
Cool.